Hi, welcome to the second session of Python programming for Revit. There are a couple of things before we actually start getting into writing code. There are a couple of things that I really want to talk about. One is the Revit API. We didn't talk about this in the first session because Revit API is directly related to writing programs for Revit. In the first session, I really tried to introduce you to some basic tools to basically have have you started setting up your systems and be prepared for finding stuff and be prepared for programming for Revit. So in this session, the first thing I want to talk about is the Revit API. Just before that, I'm gonna say that I'm assuming that all of you understand and know Python to at least to a basic level. There is one important concept that I want to talk to you about that is crucial to understanding programming for a software as complex as Revit and the way its API works is that it's a concept of a class or an object. So in programming languages that are sort of like object-oriented, you can define a class. And a class is a it's basically as a data type. So let me write this as an example. Class test. And I'm going to say that okay, so basically I just wrote a class like this. And I'm going to hit play and the code runs in Python and that class is created. So now I can say variable k equals test, which is my class. And now I have created an object of the type test. So this is very similar to the concept of, for example, if you say v equals 2, this 2 is an integer. It's a data type. So it's very similar to that, this test is also a data type. It's basically a data type that you have defined, which is custom to you and for the purpose that you want to use. What's nice about these classes is that they can have properties like this. They can have methods, which are functions that are related to their purpose, basically. So for example, if you have let's say if you have a wall, the wall could have a function on it, a method on it that you could run, and it would return the total volume of the wall, for example, or it would perform an action on the wall. Let's say, I don't know, splitting the wall. So each one of these classes with its properties and its methods that work around the concept of that class. So for example, a wall could be a data type in Revit, right? And it's a class. It has properties like area and volume and height and other kind of stuff, and it has some methods that that perform actions on that wall that are basically related to that wall. This is very important concept to understand. I'm not gonna get into too much details with it. I just want you to understand when we talk about properties and we are talking about methods, which basically they are they look like this. For example, find method. So we just added a method, which is a function basically, to our class. I'm going to actually call it something else. And then we do that, and then I'm going to create another object of type test, and I'm going to call print value on it. See, this is just like a function, but is a sub. It's a property. It's a subcomponent of this main object. That's why it's called a method. So it understands the internal properties of this class, and it can read it and write it and perform actions on it and stuff like that. So this is really the concept of class. I'm not going to get into too much detail with it, obviously. What you really as a Python programmer should know is the concept of classes and object-oriented programming in Python. So if you guys have started the tutorials but haven't gotten there yet, if you go to the Python website, to documentation, I could have actually clicked on that link, documentation, Python 2, make sure that one, because that's the version of Python that we're using, the standard version of Python that we're using in when we're programming under Revit. And then go into tutorials. And then if you scroll down, chapter 9 is all about classes, and it talks about the oriented programming, and how class can subclass from each other and stuff like that. So this is a concept that you really should be familiar with. Make sure that you understand classes and can create them in Python and can work with their methods and values and properties and stuff like that. So that's it. That's a very, very, very quick introduction on the object-oriented programming. I'm going to assume from now on, I'm going to assume that you understand this. Right after this, we're going to get into Revit's API. So Autodesk Developer, I think it's Network, which is a website that Autodesk provides. I'm going to actually type Revit here too. It's sort of a website for developers that work with Autodesk products. This section, this portion of the website is about Revit, is about programming for Revit. And if you scroll down under Tools, you can find the SDK, which stands for Software Developers Kit, for different versions of Revit which are current. This SDK has a lot of, it's an executive file that you can install on your machine, but it really doesn't install an application. It's sort of like it installs all the examples and the documentation of the API and stuff like that on your machine, so you can use it while developing application for Revit. The only thing that I'm generally interested in is these CHM files, which are the old school Windows documentation files that I really care about, because these are the ones that you can find information about Revit API and how things work, and what is, for example, what is a wall element, a wall object, and what are its properties and stuff like that. So this is like, especially this one, the first one, Revit API.chm, is really your, it should be your go-to to find information about how to do things in Revit. It has a couple of chapters, like if you go contents, you can see different namespaces that we'll talk about later, and I'll tell you about it, how things work and stuff like that. So this is the original file that gets that is provided by Autodesk. Now, Guy, a friend of mine, has created an amazing website which is called Revit API Docs. And if you search for that and make sure, you click on this, and this is the website. He basically wrote a website that is automated to read all this information from these CHM files that I showed you, and create a website around them that you can easily search, and you can compare different version changes to different that has been done into different versions of Revit, and then there are code samples on it and stuff like that. So as you see this, it's even animated, and it tells you basically how you can search for information on it. So let's actually do a search on element. And if you do that, it goes in and it loads the results, and you see a whole bunch of matches with that. Let's actually filter for element. Anyway, you get the point. So and it has the same namespace structure that I showed you in the CHM file, so you can always see stuff in here. Let me actually filter the element iterator collector. Let me actually search for something else. So this is the documentation page for this class in Revit's API, which we'll talk about this in this session. But so this is the same page. If I go to the CHM file and search for the same term, I'm actually going to do it here. Element collector, see, it's the same thing, and I can open it here, and you can see that's basically the same page. It's just that it's so much nicer in here, and you can basically, you can start discussion on it and ask questions and stuff like that. And you can also, see it for different versions of Revit, which is very convenient. What's really nice about this is that it also provides a way for us to create links to different, to different concepts and objects and definitions and documents within this Revit API documentation. So if you want to share the information about filter element collector with one of your colleagues, you can always just copy this link and share it to them. There's no way you could really do it with this because it's a it's a local file, and you kind of have to tell them to go and search for this class. So throughout the course of this course, you'll see me probably using both of these, depending on which, if I have access to internet or not. But so I've kept these on my desktop, and they're readily available. And also Revit API docs is super easy to use, and it's fast, and is well maintained. So these are the two resources that you can use to understand how Revit is working, the internals of it and stuff like that. So there are also documentations on inside Revit. I think it's Revit Help. I'm gonna search for Revit documentation. Let's search for this, and developer's guide. Yeah, so there's this developer's guide documentation that Autodesk provides in its help, in the Revit Help. It's a section, a chapter inside Revit Help that talks about how to develop applications. So it talks about there's an introduction. It says basic interaction with Revit elements, Revit geometric elements, and it goes into a little bit of detail about how things are done inside Revit. It provides very basic examples. All these examples that are referenced in this developer guide is provided inside that the SDK that we talked about. So all these examples are provided inside these SDKs that we talked about. So this is, if you want to program using C#, this is basically the best place to go. And if you understand C# enough, you can go and read these documents and basically translate that into Python. This is really what I'm trying to do here. I'm trying to share my experience in writing Python programs for Revit, so that you don't really have to go and read these documents. So we talked about the SDK, and we talked about getting help for Revit API. So basically, from now on, whenever you hear me talking about what a filter element collector is and stuff like that, I've basically collected this information by reading the Autodesk developer guide pages, and then later trying to figure out, going through this documentation and trying to figure out, reading these remarks and descriptions and stuff like that, and trying to figure out how things work in the Revit API world. I mentioned Revit API a lot. API stands for Application Programmer's Interface, or Application Programming Interface. Revit is a very complex software, and it's written in, let's say, C# language, right? It has a lot of functionality that's inside it, and we call it, they're not exposed. So third-party developers like me and you that want to create tools for this software really can't use those because they're all internal. But they decide to share some of these functionalities with the outside world. And that's why we have these documentation and SDK around those functionality that's exposed to the outside world, and we get to use them. Every once in a while, every new version of Revit that comes in, there's a what's new section on what's been added or what's been removed from the API. So those are really important to read, and basically you might, for every version of Revit, you might need to make adjustments to your scripts that you have written or the programs that you have in C# based on the new changes to the API. So API is really a sort of like an interface between us third-party developers and the software itself. Do not expect the API to provide all the functionality that you see in the software. That's all I'm trying to convey here, that do not expect that everything is possible using the API. Only the stuff that the developers of this application have decided to expose to the outside world are the ones that are exposed, and we get to use them. Okay, so we talked about the Revit API, and I mentioned the documentation and the SDK and the Revit API docs website, which is amazing. You should always use that. Um, there is the next step, which is setting up Revit Python shell. So Revit Python shell, if you click on it, it opens this shell for you, and it's very nice and stuff like that. What I really like to do is that to import the basic stuff from the Revit API here, so I get to use and play with them, and don't have to import things from Revit API. I'll get into details about this, but I just want to make sure that you set it up right now, so we don't have any problems using it from now on in the videos on the basic sort of like basic session in the basic sessions, and in the more advanced sessions I'll show you how everything is done inside that setup for the Revit Python shell. So for example, I want to, if I have an object selected here and I open my Revit Python shell, I want to be able to work with that selected object that I have basically selected inside Revit's API, Revit's interface. So the way it works is that under configuration for interactive Python shell, which is the RPS, if you go under configure, there is a tab that calls init script and startup script. There are two scripts that are very important. The first one, well, let's talk about the startup script. The startup script gets executed every time you're starting up Revit, and Revit basically calls Revit Python shell, and Revit Python shell starts up and creates its own buttons and stuff like that in here. That's when the startup script gets executed. The init script, which is the one that I'm interested in, is basically a script that gets executed every time you open the interactive Python shell. So basically, every time you open it, that script sets up the environment in here, so it can work easier and have the stuff that you want based on your preferences and stuff like that. And I'll show you in a minute how it works basically. So if you go I'm gonna actually, let's keep these open. If you go in the pyRevit repo, the repository on GitHub, and then click on me, and then actually go on gists, I think that's how it works. I shared a link for this to the under the YouTube video, but basically I've shared my configuration of RPS in a file that says rps_init. So if you click on that, you'll see that this is a Python script that I have that basically gets executed every time I open RPS. So what it does is that from the Autodesk Revit API, from the database and from UI modules, it imports everything basically so I can use them easily, and then imports CLR, which is also a very important component that basically provides some functionality for IronPython to be able to talk to C# libraries. And I add some presentation core, some Windows forms and stuff like that, so I can add create windows and things like that in there. But the most important part really is this bottom part, which is that we'll talk about these in detail later, so you don't really need to worry about them right now. I'll tell you about the difference between document and a UI document and the selection and things like that, and how you're getting them from Revit. Right now, my core purpose for this session is that to show you, to basically get you started really quickly with writing one very simple script for Revit, and creating a button for it in pyRevit. So just get things started and let you help you be able to play with things, and we'll get more advanced as we basically go through the sessions. So basically here I'm asking Revit for the current document. We'll talk about the UI document later, and I'm asking Revit for the current selection. I'm also providing two functions, two Python functions. One is for alert, that basically uses Revit's API to show a dialog, basically a prompt dialog with a message, so I can do that. And then using a simple function that is Pythonic, and it looks like any other Python function. And then quit, which basically closes the window, closes the RPS. So I can put quit inside my script, and when I run it at the at any place that it decides the script should end, it could close the RPS window. And then basically through the selection, I go check if the number of selection, if the length of the selection is more than is bigger than 0, means some objects are selected, then pick the first selected object and assign it to EL, which is short for element. These are all my preferences. You can adjust this file the way you want it, add more functions and whatever you want to this to customize it for your own environment. I'm providing this to you just to get things started at the moment. So make sure that you go under your Revit Python shell and configure and assign. First of all, obviously download that file in Python format, obviously, and put it somewhere on your on your machine, and then point to it this way, so it gets added in here, and then every time you run the Revit Python shell, you'll be able to, that script gets executed. For example, I have an object selected here, and if I say EL, you can see that that variable contains something, which is an object that we'll talk about more in detail. Okay, I think we are kind of ready to start actually writing a little program for Revit. So the first thing I want to talk to you about is how to, a very simple basic way of getting a list of objects from Revit so that we can work with them. So the purpose of this is that I have an idea. I want to write a script that collects the total, let's say, volume of all these walls. If I click on them, you can see the volume in here listed in the properties. So each one of these objects, each one of these walls have a property that is the volume. I want to be able to write a script that collects this data from these objects and basically adds them up together and spits out the output. So the way to do it basically is that you can query information from Revit, or you can query information from a user. The difference between these two is that I can ask Revit to give me a list of walls, and then I filter those walls inside the program based on the properties that I decide that they should be filtered to, and collect the information that I need. For example, if I want to collect all the volume for all the walls that are 20 feet high, I can ask Revit for all the walls and then check the walls and filter out the ones that have that property at the unconnected height, let's say, is at 20 feet, and then filter my basically results, and then go and collect the other properties on these objects. Or you can ask the user to select those objects for you. So basically, we can work both with selected objects, or we can query the information that we need from Revit and in multiple steps basically filter them down to what exactly we need. And then once we have that set of elements that we want to work with, then we'll do whatever we want to do. If we want to collect information from them, or we want to basically make some changes to them, and things like that. So the first step is to collect the element set that we want to work with. The way in Revit the way to collect elements in Revit is to basically use this filtered element collector class. You can hear me referring to element a lot. I'll get to detail about this later, but assuming that you're familiar with the concept of object-oriented programming, the element is a master class, which is called the element class, which is the parent to all the objects in Revit. So it provides the basic functionality to all these. For example, if I scroll down on this and let's say pick something that is more familiar, let's say material. See, material is a subclass of the parent element. That's why when we get into the programming world for Revit, we'll start calling these objects that we're collecting elements, because that's what they really are inside the Revit environment, inside the Revit API environment. This helps you get the verbiage right, so it's easier to understand how things are going and how to find things and stuff like that. So that's why I'm referring to them as elements. We use in Revit API, we use the filtered element collector, which is a class provided by Revit API to collect elements from Revit's database. Revit database being the document that's open, that has a lot of objects of different types, walls, roofs, all sorts of stuff in it, and we want to collect some information from that uh, database. The concepts of the internals of how this thing works is really complex because Revit deals with such a huge and giant database of things of completely different types. You have plan views and section views and 3D views, and you have view templates, and you have walls and roofs and all sorts of stuff within the same database. And Revit needs to really provide a very efficient collector system to basically allow the developers to collect information from that database. So the first thing we need to do is to create an instance of that class. So what I'm going to actually open a text so I can write the script in here. So I'm going to say let's say call it CL for collector equals filtered element collector, and I'm going to add the parentheses at the end because this is a type and we're creating a new instance of that type. So now CL is our collector. It doesn't really have anything inside it. We still have to tell it what type of object we are trying to collect. So how do we determine this? We should go into documentation and look at the properties and methods that are available under this class. So if I go scroll down onto the bottom of the screen, there's an important section that you can see this basically line on any class definition that you can see in the API. It basically directs you to a page that lists the members of this class. The members being the properties and the methods of that class. So if I click on this, you can see this in more detail. Let's forget about the constructors. You can see the methods in here. These methods are functions that do actions or collect information and basically do something on that object, on that data type or class, which is this, right? So for example, there is a method for first element. What it does is that it basically tells filter element collector to return the first element that is contained inside this class, right? And then if you scroll down, you can see a list of all these different methods that are provided on this. One of them that we are really interested in right now is the of category method. So the description says applies an element category filter to the collector. If I click on it, I can go into the documentation of that method only. So basically, I'm not going to look at under Visual C++ or Visual Basic. Let's just stick with C#. Obviously, there are no Python examples for this, and that's really why Guy started creating the Revit API docs, which is this website. So we can, over time, we can add the examples for Python to this. So you can see the definition of this this method in here. It could look a little bit complex if you don't understand C#. I'm gonna give you a sort of like an example of how these things should be read, so you can have an easier you can understand these methods better when you're working with the API. So basically, this is the method name. This is the type of object that it returns, which is the name that's before that name, whatever that is, it's the object that it returns. And between the parentheses, whatever that's provided here, are the information that you have to provide to this method for it to be able to do its thing and then return the provided value, right? So we need to tell of category what category of objects we are interested in. And basically, to do that, we need to understand what is a built-in category. Built-in category is another class that I'm going to open here in the documentation that Revit has inside its API that is an enumeration. Enumeration is a data type that is basically sort of like a list of specific things, right? So built-in category has all these members under it, which are standard objects and elements and components that Revit understands. For example, we can go under OST and scroll down and find, actually have to scroll down more. Or if it's a very big list, we should actually start searching for stuff. So I can search for wall. Okay, get to this, wall tags, stacked walls, wall collectors, walls, default, wall insulation. Okay, there we go, we found. So it says OSD walls. This is the default built-in category for walls in Revit. So this is how we communicate with the API. This is how I tell Revit I want the walls. When I say walls, when I want to convey this information to Revit, I have to use one of its standard built-in categories because this is what it understands. I can't just just type in give me the walls. So you have to do it in its own language. This is basically in the language that you talk to Revit in. So what we collected so far is this, that in my script, on my collector, I can use the off category method, and then I need to provide that built-in type that we talked about to it. I need to tell the off category I need the walls. So I should say, and I have to start with the built-in category again because all these other members are member of this. So I need that. Built-in category, and we go to the members and we say OSD walls. And that's the type of walls that we needed to use. So far, we have created a collector that is basically the base class. This is the collector object that we want to deal with. We tell this object what kind of objects that we want to need, and gradually filter down all the elements that we are looking into. And on the next step, I've told it to, okay, I need all the objects of this specific built-in category, which are the walls, right? Okay, so I'm going to do this, and I'm going to copy that, and I'm going to bring this into my Revit Python shell and paste it here. And I'm going to run it. Oh, okay. So one thing that I forgot, filter element collector, that's why you should basically check the API. Filter element collector, if you go back, the parts that we missed, that we didn't talk about, is the constructors. So all these objects really that you find in the API has a section that are constructors. This is basically part of the documentation that tells you how to create an instance of this object of class. So there are 3 different ways that we can create one. Well, we don't get into too much details about this. The first one, which is the simplest one, why? Because for me, it needs the least amount of information here. See, it needs 2 different things, but the first one needs there's only one. And what we need to provide to the filter element collector is the document that we are interested in. The reason for this is that inside you might have like 5 different projects open inside the same Revit session, and when you're talking to Revit, you have to kind of tell it which one of these documents you're interested in. For this, I'm going to use doc that we defined in the setup script for Revit Python shell that basically grabs the active document. So if you have 5 different documents open inside Revit, this script works on the one that's active here right now, right? Why? Because the doc is the active document we are providing to the filter element collector, and basically filtering the elements that are inside this doc. So, okay, let's play again. No errors this time. Perfect. Okay, so if I type CL, let's see if it worked correctly or not. Okay, let me actually close that and open it again so we do it like cleanly this time. Okay, CL. Okay, there we go. So this CL, which is a variable inside the Python environment that we're running, when I click on it, when I enter its name and hit enter, I basically get what that object is. And if you see, it says Autodesk Revit DB, which is its database module, and filter element collector. So this is an instance of this class. And we created it correctly because we provided the document to it, and we used one of its methods to filter down, oh, not this one, sorry. One of its methods, which was the off category, and for the method, we also provided the correct information to that method, which was the built-in category. And so this CL really should include all the walls in this Revit document right now. So again, I'm assuming that you understand the Python language. The CL object is an iterative object. So I can use it within a for loop. So I can say for element in CL print element. Oh, okay. So what does it mean is that you can iterate over this object, which is the filter element collector, one by one, get it inside this, and then use it in however that you want. This is a standard Python system, a Python for loop, right? So I just looped over this, and I got 1, 2, 3, 4, 5, 6 different objects back. Now, if you see, that's the way I generally print this, is to sort of like check to see if I provide the built-in wall category to Revit, to its filter element collector, what kind of objects does it actually return to me. So you can see that it has returned 4 walls, which obviously I can see them right here. These are the only walls that I have in the model, so obviously it has returned the 4 walls, and it also has returned 2 wall types. That are basically, so wall types are the types that these walls are using, are, they belong to. They are part of the walls category as Revit API has defined. Sometimes it might not kind of make sense to you that why things are done in certain ways in Revit, but this is the part that I was talking about, that you can't expect it to behave exactly the way you want it. This is how the developers have decided to implement these features. You should always check and test the returns that you're getting from the filter element collector, because the type of elements that Revit works with are so vast, and you have so many different programmers working on different sections of this software, that you might not have consistency always within these results. So for example, maybe for one of these object types, maybe it doesn't return the types of those objects. I'm not saying that this is the case. I'm just emphasizing that you should always check the results to make sure that that's what you want to. So what we need to do right now is, we don't want the wall types, because the wall type doesn't have a volume, right? It's just a type. I need the volume of the wall itself. And if I iterate over these list of objects, I'm going to pass over the wall types, and they don't have the property of volume, and then I'm going to run into trouble. So the proper way to do this is to filter down our set of elements one more step to make sure that we don't have any of the types listed, and we are returning only the walls. So I'm just going to copy this again and put it in my notepad. And so that's the doc is correct. So what is the next step? Okay, I need to go look at the filter element collector again, see if it's providing any other methods for me to be able to filter the selection down a little bit more. So I'll go, scroll down. Oh, now look at these. It says where element is not element type. Oh, that's great. That's exactly what I needed. This is another method. So if I click on this and go inside the definition, oh, this method doesn't even need any information. So I can just run this method on that collector object, and what it does, it basically filters down. I'm actually going to write it in a new line so it's easier to understand it, kind of, the 3 steps that we're doing. So, okay, so the CL object is the same object, that's just, we're reusing it in every step. So in the step 2, we, picked all the walls. In the step 3, we are telling it, do not include any element type. Okay, so this should be simple. So I can copy this, go back to Revit, open my interactive Python shell, paste the stuff in here, create that, check the CL, yes, it's good. For EL in CL, print EL. Oh, nice. See, it's not returning the wall types anymore. That's exactly what I wanted. Okay, so we basically wrote in 3 lines the first part of our script, that is, its job is basically to collect information, right? One more way we can simplify, obviously, this, as you're familiar with Python, we can simplify this by removing these extra lines and just do this, right? Because we're dealing with the same object. So basically, we can write this whole thing in 1 line that only returns the wall objects for us. And then I'm not sure if I can do the len CL. No, okay, so let's do len of list of CL. You should understand this, what I'm doing right now, if you understand Python. I am converting the collector into a list, which is a standard Python data type, and I'm taking its length. So, okay, the length is 4. It means that CL contains 4 objects, and I'm pretty sure that's the 4 walls that we have created, because we have really tested it in multiple different steps. Okay, perfect. This is exactly what I wanted. I have the 4 walls now. Okay, so we're going to keep this here. One other thing that I just wanted to mention to you is that this script worked inside our Revit Python shell environment because of all these extra imports that we did right here inside this. See, from DB I imported everything. That's why Python is not showing you an error for this data type or for this data type, right? Because it understands that these came from this. It's imported all those in the current global namespace of the script that we're working with. When you're working with, if you want to write like efficient, proper programs, we should really import the stuff that we need from the modules. And the way I know that this is part of this module is because if I go into the filter definition, filter element collector, under the members, it actually says it here, but I want to go to its master page basically. Okay, so see on top of this it says Autodesk Revit DB. That's where this class exists. That's the namespace that this class inside lives inside it. In Python, we don't generally talk about namespaces as much. Namespace is a very familiar concept to C# programmers. It basically provides containers to put things in them, to put these classes in them. The main thing for this is to sort of like categorize the things that you're working with. So I'm going to actually open this documentation that we have, the CHM file. So all these stuff listed here are namespaces. So Revit DB architecture has its own namespace because it has all the things and objects and rooms and components that are sort of like related to architecture only. Mechanical, for example, has its own namespace, and each one of them, the pieces with a dot is its own namespace also. So mechanical is a namespace that is inside the DB namespace, that is inside the Revit namespace, that's inside the Autodesk namespace. That's really what namespaces are. They're just sort of like folders to categorize things in, right? So that's why we have to tell Python to import filter element collector and built-in category from the Autodesk Revit DB namespace, right? So we can work with them, because Python itself doesn't understand what filter element collector is. We have to tell it, we have to import this definition and definition for this class from that namespace into the the global namespace that we're working with in Python for Python to be able to understand what we're doing. Same thing with this. We don't obviously need to import all of these other ones, the methods, because these are sub-methods of this object. And when this object gets imported, it brings all the definitions of the methods and properties with it. So you only have to basically import the master classes, right? So the filter element and the built-in category. These two are completely different things. So the OSD walls is part of this. It understands that. Okay, so we imported the right stuff that we needed from Revit. We created the collector. We collected the walls that we needed, but we want to work with inside Revit, and we are ready to collect some information from those objects. So the first part is that I'm going to create a for loop and say wall for wall in CL. Actually, we can rename this to make it nicer now. We can say wall collector instead of CL. So this script, if somebody else finds this script somewhere and reads it, they can understand what's going on, right? Okay. And in the habit of, good programming, you should always document what's going on. So I'm gonna do, okay, creating collector instance and collecting all the walls from the model. Okay. This is just a note that we added in Python, right? It's a note before this. This is not an executing, it's not a statement. And for this, okay, iterate over walls and collect volume data. Okay, cool. And what needs to happen is that as I'm iterating over these objects, I need to be able to collect and add these values to in one container so I can print it later. So what I'm going to do right before this is to create a total volume property variable and set it to 0. So basically inside this, I'll be able to, and I'm going to save this as a Python file so I can get the syntax highlighting. I'm going to just call it test for now. I'm going to save it on my desktop. Okay, so at least I get the syntax highlighting here. Now it's nicer. You can see all the green ones are the notes or the comments inside the script file. Okay, so we have the wall. We are iterating over the wall collector and picking walls, each one of the walls at every step. At this step, right after that, I need to read the volume of that wall. Okay, so how do you do this? I would love to say wall.volume, right? Because volume should be a property of the wall. Let's see if it has that property. How do we do this? The wall is an object inside the Revit API, right? And if you remember, it said db. Let's actually run that again. I need this much of that. And I'm gonna go inside this, paste it in my pad, and say print wall. In Python 2, you can skip the parentheses after print, but get into a habit of doing this because later we're going to move to Python 3, hopefully in the future, and that's standard in Python 3. So, okay. Oh, okay. So these walls are of type Autodesk Revit DB wall. Okay, so let's go find that in the documentation. Let's go search for wall. And Guy is actually working on this right now, so the results are sort of like, ordered better. Wall class, there we go. Okay, so Autodesk Revit DB wall class. Let's click on it. Okay, so this is the definition for the wall class, the documentation for it. Cool. On the other side, you can see that there are 3 other pages that are standard. You can see these 3 pages on all these, different classes and objects that we work with. The first one lists all the members. The other 2 are sort of like filtering the first one, only listing methods and only listing the properties. I'll tell you more about the differences between these 2, but you really should understand this if you understand object-oriented programming and classes and stuff like this. You really should know the difference between these 2. I'm going to click on this so I can see everything. Okay, so what I'm doing is that I'm checking the properties and methods of the wall type, right? Okay, so let's go down, and on the methods, there is not a method that says like get volume or something like this, right? I can't see anything. Okay, so it's probably not here. Let's go check the properties. The properties are not methods, they're not functions, they contain values, right? So let's say if there is a volume in here. There is not a volume. Okay, so how can we do this? Wall is if I go back to the wall class definition, you can see, if I scroll down, you can see that wall is basically a subclass of host object, which is also a subclass of the DB element. If you remember, I talked about element is sort of like the parent to almost everything in Revit's database, right? What's nice about this is that it provides some functionality that is available in all the other elements and objects that have subclassed from this class, right? This is a basic concept in object-oriented programming. So if I open element, I can see that in the element definition, actually I need to wait for this page to load. Okay, I want to see the members of the element. And I can see, scroll down and see all these methods. One of them that I'm interested in right now that we'll start talking about is the, there we go, lookup parameter. So see that's a method. And if I go back to the wall class, under the members, let's click here, wall members. Oh, there we go. It's the same thing. And see, it says inherited from element. In element means the architect, this element that was listed here, right? Autodesk Revit, the DB element. Actually, it was somewhere else. Sorry. So that's the element that's inherited. This method is inherited from, right? So all these objects that are subclass from element have this parameter, have this method. And what does it do is that I should actually read the documentation for it, but that's it. Attempts to find a parameter on the element which has a given name. Okay, that's what we want. So we couldn't find the volume as a standard C# parameter on this class. So we kind of have to ask Revit for that parameter. The way it works is that lookup parameter is the method name. We have to give it the name of the parameter in string format. So we just type in the name, and then it would return a parameter object to us. Now, this seems a little bit excessive and complex, but you kind of need to understand that this software is a software that's used around the world with different languages and stuff like that. So maybe the volume that is on a wall listed here, maybe it's called something else in a different language. And that's kind of the reason why each one of these properties on an object, it's an object by itself and has its own properties. So if I use, actually, let's select one of these walls and say, I'm going to test that method right now. So EL is my wall, el.lookup parameter. It's a method. I'm going to type the parameter that I want, volume, and this is how you do strings in Python. Okay, I'm good to go. Oh, see, the return value is a parameter object as was told in the documentation. It's a parameter object. So what is a parameter object? A parameter object, a parameter class, includes the definition for a parameter that Revit works with. You can read this later, this whole documentation in it. It describes exactly what it does. But I'm going to tell you a few things about the parameters that are sort of like consistent, because almost everything that you get from the lookup parameter is a parameter. What does it do is that, let's go under the members. It contains a value, the value of that parameter, right? But it also has a piece that's called definition. Let's say go here, definition, right? Definition in itself is an object. So you can see that we are getting really deep into the API right now. So definition itself is also an object and has multiple different properties under it. So if I go definition, and you can see there's still other definition classes that are subclass from the definition itself. So it's really easy to get really deep into the API. So you kind of have to like at least like keep the pages open like this, so you can kind of like understand where you've been and where you're going to. So see, definition has a couple of other properties to it. So name, parameter group, parameter type, unit type. We're interested in name right now. So I know it's getting a little bit confusing, but stay with me. Okay, so we know that el.lookupParameter, that the lookupParameter method on the wall object return a parameter object for the volume property that we asked for, right? Okay, so I should say p equals that, so I can remember that assign it to a variable. So p is that property. So p has a subproperty, which is a definition that I showed you, and that definition has another property, which is name, and see, that property is defined with the name volume. Okay, another property of the parameter object is storage type, and it's listed under parameter class here. Storage type describes the type that's used internally within the parameter to store its value. So some of these parameters inside Revit, I should minimize this. Some of these parameters are inside Revit they have values, like integer values. Some of them have double floating values, like this. Some of them are strings. Some of them are on and off, Boolean variables like room bounding and stuff like that. So there are multiple different types of these data types that a parameter can contain. So the storage type, if I just check this, storage type for the parameter for volume is a double. And see, this is storage type. That's also inside the namespace of this. It just doesn't say double using the Python's standard double. That storage type is also defined inside the Revit API. So we can go into documentation and see all the other types that are belong to the storage type. I can actually show them to you here. So they are like double element. It could be an element ID. It could be an integer. It could be a string. So the different types of storage types available for Revit properties. So we just checked it. I'm using RPS as my sketchpad basically. We just checked it that if you get the volume parameter, the storage type is of type double, which means it's a floating number. Like for example, like what? Like 1.3. Like that's technically a double. Okay, so I gave you just a quick introduction of what a parameter is and how you can get it, right? We'll work with this parameter later and much more within the this tutorial session, but I just want you to understand that things are a little bit more complex than Python itself. In Python, generally, you never have to do this, right? You can get the property of a class just by calling it and say, maybe, I don't know, wall.volume. That should be like this. It's super simple. But then understand that this software is much more complex and it needs to work in a much bigger environment, and these properties have other properties and other components of themselves, so they become more complex objects and stuff like that. Anyway, we learned how to get the volume from the object. I'm going to copy that piece of code and I'm going to go back to my code and paste it here. And I don't need the EL part. Why? Because I have the wall, right? So for every wall, go here, look up the parameter volume and assign it to let's say vol param. Get into a habit of naming your variables correctly so you know what each variable is. Okay, so one quick thing, always check the return values of these methods. Why? Because maybe that object doesn't have the volume property. If it doesn't, this method is going to return a null object. So I'm going to say, on the next step, I'm going to say if vol param, and this is standard in Python, so I can say if that object exists, if it's not none or null, do the next step. Okay, so we tried to get the parameter from Revit. We checked if something has been returned, and then we say, okay, so now total volume equals the previous total volume. This is like the basic programming stuff. So I'm sorry that I'm taking, getting too detailed into this, but I'm sort of like addressing a whole, a big range of audience here. Okay, so total volume equals total volume plus the value that we're getting. So total volume, and we already know that this, we already checked that this parameter is of the storage type. The contents of this parameter is of type double. So I should have shown you that, but let's just go into documentation. So for the parameter objects, you have a couple of methods that return the values in different ways. So although, for example, although the contents of this parameter, the value is of form double, you can always sort of like get it as a value string also, or as a string also. So you can basically just some internal conversions for you. If you need that value as a string or as a double, you can get it in different ways. I'm going to use as double for now because that's what I really want. I want the actual value. So I'm going to say double, which is a method on that object, and that's it, right? Okay, so we added that into this, and we added it to the total that we had collected. Okay, so, and then I can go the end and say print. I'm actually going to type a note in here that says, now that results are collected, print the total. Okay, print total volume is, and I'm going to use a standard Python string formatting system, and I'm going to put the total volume that we have collected in here. Okay, beautiful. Copy all. Let's test our script. Don't have to have any object selected. Open the RPS, paste stuff in here, and hit play. Beautiful. Total volume is 296.1157, and the unit is cubic feet, as you saw here. So if you need to convert it to other stuff, you can always do more conversion to it, to this number. But basically, we collected the volume of all these walls that are inside the model. Now you can run this script on a model that has like 2,000 walls in it. It would run slightly slower, but it is model independent basically. So it doesn't really care how many objects are returning. If this wall collector returns 200 different walls, the loop is just going to continue adding those volumes up until this basically until it's done with all the elements that we return. And if it's only one, it's only one. If it's zero, nothing happens. The loop will never do even its first round, so the total volume would be zero, right? If there are no walls inside the model. Okay, so we wrote basically our first script inside this. You can hit save, and you can go save it on your desktop. Call it total volume.py. Beautiful. Okay, so next time we open RPS, you can open, and we can go on the desktop and say total volume and open that, and we have the script. Beautiful, and we can hit run. So we can close the model, open another model, open RPS, load this in here, and hit play, and it would return the total value again for you, right? Easy peasy. Okay, so we created the script that we really wanted. I think we touched upon so many different subjects in here, and I know that you are kind of sort of like confused right now. That oh my god, this is a lot more complex than what I thought it would be. But this is how I really learned. I didn't know anything about Revit programming 3 years ago, and this is how I really basically learned it. So it's step by step, baby steps, and what it really helps is that you can always go inside the pyRevit scripts and see how things are done, how information is collected and things like that. I have not really done a really good job over the years of documenting these scripts. So some of them are nicer, some of them are not. So apologize for that. We are in the process of rewriting and relooking at these documents to make sure that they're kind of like documented properly and everybody can read them and things like that. Okay, so in the next step, I'll show you how to add this script to the pyRevit. So we have this tool available in our maybe a new tab. So instead of running RPS, load that script and run it and stuff like that, we can just click on that button and it would read all the walls that we have, and it would return the total value of the walls to us.